Welcome back once again, friends. In this video, we shall continue our journey into the world of turtle graphics. We are going to see how we can draw a square. Now, obviously, square is a very simple shape. There are more than one methods of doing it. But really, my intention in this video is to give you a familiarity with the basic turtle methods, which will allow us to make the turtle do things for us. So recall that when we run a turtle ripple and we do these two commands, which is import turtle and t equals to turtle.turtle, we get a familiar, we get a turtle on the stage which is basically ready to take our commands. As I also told you that this turtle is in fact very very similar to the cat sprite, which is just waiting for us to command it, right? For a start, notice that sprite is standing at position of x and y 0, 0. We'll see the turtle also has x and y coordinates, and in fact, they are quite similar to what we are seeing here. Also, you might remember that to make my sprite go around the stage, we can use the go to block, which basically, for example, if I say go to say 100, 0, say 100, 100, then I know it's going to go forward 100 steps and also go up 100 steps because X is the movement along sleeping line, Y is the movement along the standing line, and that's exactly what I'm expecting. And if I did this, oh sorry, I need to do this. If I clicked on this, it's going to go over here, right? So basically the concept of xy coordinates, the concept of go to and so on and so forth is in fact very similar in scratch as well as in turtle, right? So let's see how we do the same thing in turtle. Basically I go in here. I can see first where the turtle is positioned right now, so I can use in the console this command t.position. I must use this two ending brackets because only then the method position gets executed, right? So if I did this, notice it says 0, 0, and that's simply because the center of the stage, just like in scratch, is also x value of 0, y value of 0, right? There are other methods also you can use, for example, x pause, y pause, and so on, very similar to what we have in scratch. Now let's make our sprite move around a little bit. So in fact, what I'm going to do is that I'm going to say, hey sprite, hey turtle, go to say t dot go to. For instance, I might say minus 100 and 100. Right now, what this will do is that just like we expect, it will come back 100 steps and then go up 100 steps. So I expect my turtle to end up somewhere here. If I run this command, indeed, that is what happens. The turtle actually comes back up there, right? And we also notice the turtle draws a line. We'll talk about that in a moment, but let's just complete this causation here to make it go around a square. So basically, right now it's at minus 100, 100. I can make it go to say 100, 100, 100 minus 100, and then minus 100, minus 100, and back to minus 100, 100, and that will complete a square. So let's just do that first and see how our turtle. So I'm going to copy this, let's say, and say, so 5 commands of this sort. Like I said, minus 100 starts, I take it to 100, 100, then I bring it down to 100 minus 100, and then I say, okay, look, go to minus 100 minus 100, and then finally come up to say, so go to minus 100, 100, and then finally come back to minus 100, 100, right? So if I do this, I do expect turtle to go to the to create a square path for me, move around the square path. Notice everything being mentioned about the turtle is always t full stop, like a dot, go to, or previously we used t dot position. So this basically tells you, it's like telling the turtle to do something, right? So remember the turtle's name here was t, so we're telling hey t dot, basically execute the method go to, do that for us, right? So that's why we don't use this t dot notation. Now, if I do that, yes, I get a square, but as we would have probably anticipated, we also get this extra line. Now, before I talk about this, I just want to kind of like flashback a little bit. Remember, long back, we had done this in Scratch. And whenever you drew this line without taking care of pen up and pen down, you would get this the square without taking care of pen up and down. You would get this extra line, right? Now, in fact, the same thing is going on. And the remedy came from using what is called pen up in Scratch. Turns out in Turtle also we have the same exact method called pen up and pen down. The difference between Turtle and Scratch really is that in Turtle by default, which means by when I start the Turtle first, it's always pen down, and which is exactly why it drew the first line which in the square, right? So if I want to avoid this, what I can do is that I can ask Turtle to say t dot pen up. Now I must do t dot something, and also in the pen up I must give these two brackets. I take it to the original point and then I say t.pendown. Right now, these two are exactly the same as what happens in Scratch. So it's going to put the pen down after reaching the initial point, and then it's going to trace out that circle, right? So if I did that, notice what happens. I get a circle, I get a square exactly as I had imagined. Now, recall that in Scratch, we had in fact two blocks which were similar. There was a go-to block, and then there was this glide block, which is actually quite similar to go-to, except that Sprite used to sort of glide to that point, which means it used to have a smooth motion, right? Notice if I did, okay, so if I click on this thing, if I click on this here, Sprite actually, so I can try it once more. So I say minus 100, minus 100. If I click on minus 100, minus 100, Sprite sort of glides to this point, right? Now, if you have been observant, you'll notice that in fact the go-to in turtle is kind of like glide, right? So let's see it carefully. It's in fact the turtle sort of does what glide would do in Scratch, right? Now we can control how fast the turtle moves by using this method called t.speed, right? So if I go to t.speed, for example, speed could be any number between 0 and 10. It's quite interesting. 1 is actually so let's try 1 first, right? If I try, let's say 1, it's actually the slowest the turtle could be, right? So if you run this now, you'll notice that the turtle actually goes a lot slower than what it was going earlier, which was probably 5 or 6. Now let's say I do try 10, turtle is going to become much faster at whatever it is doing. Notice it is quite a bit fast, but now let's just try 0. Now 0 means it's not going to animate at all, which means it will in fact become like the Scratch go to. Notice the square just appears because it has now become like go to. Now again, do I need to remember all this like by heart? No need, because I can just go in here and I can look at turtle methods, and there is a method called speed over here, which is what I used. As I told you, it's a number between the input is basically a number between 0 and 10. 1 to 10 enforce increasingly faster animation, and speed equals 0 means the jump becomes instant, right? So it's like becoming like go to. So like I said, that list is really exhaustive and we should make use of it, right? Now before I move forward, let's just try one more method, which is to change the pen size of this of the drawing we're drawing. In fact, you guessed it, the method here is t.pensize. Let's say I call it, say, maybe 5. It's exactly, in fact, we had the set pen size in the pen platform, in the pen extension in Scratch. So if I did that, notice what's going to happen is that I'm going to get a much, much thicker square. And so you see the similarity in the blocks that we had here, and for example, in the pen extension. So if I go in here and I call it the pen extension, you will notice that turtle's blocks are in fact very similar. Later on, we'll be setting color as well. We have pen down, pen up. We are able to set the pen size and so on and so forth, right? Now, before I wrap this thing up, right, like I told you before, doing a square is actually quite a simple program. In fact, we can take an alternative approach, which a lot of students might want to do, which is that, I'm going to say, instead of making it go to say specific coordinates, x and y values, I'm going to say, hey, look, why don't you put yourself in a loop? So I use a for loop here, move forward some steps and take a right turn. Right now, those of you who know angles will find that this is actually very appealing, because number one, this code is more concise, right? Number two, you do not have to remember the exact x and y values. You don't have to mentally calculate them. And number three, this code is in fact quite flexible, right? So the same code, by changing this range and this angle, we can make it draw, for example, a pentagon, an hexagon, an octagon, and so on and so forth. So it's actually very general. However, to understand this properly, we must know what is the meaning of angles. So I'm not getting into that. As you learn more mathematics, it will become more and more clear. But it's interesting to compare and contrast this with the corresponding Scratch code. This is something I've spoken about in another video. Basically, I'm also using a repeat loop here. It's kind of equivalent to the for loop here. Notice a 4 here and the 4 here. I move 200 steps, which is equal to forward, t dot forward, say 200. I turn right by 90 degrees, and again there is a t dot right 90. So this is, also in the beginning, I set heading is like point direction. The point is these blocks are a little bit different, but they're also very similar. In the end, the logic counts, and you can clearly see the similarity between this logic and this logic here, right? So on that note, I will wrap this up here. Enjoy, have fun, practice, because practice is what will make you really learn this thing. Take care. Thank you so much. Bye bye.